Ever wondered what makes your computer's memory tick? Well, it's time to dive into the world of dynamic random access memory, or as you may know it, DRAM. This technological marvel is a type of volatile semiconductor memory. But what does that mean, you ask? Simply put, it's a kind of memory that needs power to maintain the information it holds. The moment the power goes off, all the data disappears, hence the term volatile. Now, where does DRAM fit into this picture? Well, it's used as the main memory in your computers and a plethora of other electronic devices. Each bit of data is stored in a separate capacitor within an integrated circuit. This makes DRAM an integral part of your everyday tech, silently working in the background, storing and refreshing data constantly. Ready to unravel the mysteries of DRAM? Then stick around, as we're just getting started. To understand how DRAM operates, you first need to grasp its key characteristics. An integral aspect of DRAM's structure is its capacitor-based storage. Each bit of data is nestled within a capacitor inside a memory cell. The charge stored in this capacitor, in turn, represents a binary state, either a 0 or 1. Now, unlike its static counterpart, DRAM supports both read and write operations. But there's a catch. Reading data in DRAM is a bit of a double-edged sword. It's a destructive process that requires the data to be rewritten after each read. This leads us to another key characteristic of DRAM, refreshing. Because DRAM cells are susceptible to charge leakage over time, we need to regularly refresh them. This periodic refreshing rewrites the data, compensating for any charge loss. One of the key strengths of DRAM is its higher storage density. DRAM cells are more compact than SRAM cells, which allows for a larger amount of memory in a smaller form. This makes DRAM the go-to choice when a large amount of memory is required in a limited space. But every silver lining has a cloud, and in the case of DRAM, it's slower access times. Compared to SRAM, DRAM lags behind a bit. However, it fits perfectly in scenarios where speed isn't the primary concern. Now let's talk about money. DRAM typically comes at a lower cost per bit than SRAM. This makes it a cost-effective solution for providing large amounts of memory. Finally, one of the most common applications of DRAM is as the main memory, or RAM, in computers and other electronic devices. It serves as a temporary storage for data and instructions that the CPU actively uses. So, every time you're working on your computer, you're interacting with DRAM. Now, with a solid understanding of DRAM's characteristics, we can delve deeper into its different types. Like all technologies, DRAM comes in various flavors, each with its unique features. First on our list is asynchronous DRAM. This is the traditional DRAM, operating independently of the system clock. It's like that friend who marches to the beat of their own drum, not always in sync but always reliable. Next we have synchronous DRAM or STRAM. Picture a rower in a boat, every stroke perfectly timed with the rhythm of the rowing team. That's STRAM for you, syncing its operations with the system clock for improved performance. Now let's talk about Rambus DRAM, also known as RDRAM. Developed by Rambus Inc., this type of DRAM uses a high-speed serial interface. It was the hot new thing in the late 90s and early 2000s, but it's less common these days. Moving on, we have a series of SDRAMs that are like the sequels to a great film. These are the DDR SDRAMs, which stand for Double Data Rate SDRAMs. DDR, DDR2, DDR3, DDR4, each one improving on the last, have evolved to increase data transfer rates. It's like your favorite film series, but with each sequel the action gets faster and the thrills get more intense. Last but not least, we have graphics DRAM or GDDR. This is a specialized type of DRAM designed for use in graphics processing units or GPUs. It's like the artist of the DRAM family, optimized for high bandwidth and commonly used in graphics cards. So there you have it. From the traditional asynchronous DRAM to the specialized graphics DRAM, these different types of DRAM cater to various needs. Whether it's for general computing or high-end graphics processing, there's a type of DRAM for it. These different types of DRAM are designed to cater to the diverse needs of various applications. So, where exactly do we use DRAM? Let's explore its applications. One of the most common places you'll find DRAM is in the main memory of computers and servers. Here, it provides temporary storage for data and instructions that the Central Processing Unit, or CPU, actively uses. This is the working memory of your computer, the place where all the magic happens. But DRAM isn't confined to your computer's motherboard. It's also a star player in the realm of graphics processing units, or GPUs. A specialized form of DRAM, known as graphics DRAM or GDDR, is commonly found in graphics cards and GPUs. They're optimized for high bandwidth and are essential for rendering those stunning visuals in your favorite video games or processing high-definition video content. Next, let's talk mobile. Smartphones, tablets, and other mobile devices also rely heavily on DRAM. It's the system memory that allows your apps and operating systems to run smoothly. Whether you're swiping through social media, streaming a movie, or navigating with a GPS app, DRAM is quietly working in the background, making it all possible. And it doesn't stop there. DRAM has also found its way into a variety of consumer electronics. From televisions to cameras to audio devices, DRAM is there for data storage and processing. It's what allows your smart TV to stream content, your digital camera to process images, and your home audio system to deliver crystal clear sound. Finally, let's not forget about networking equipment. Routers, switches, and similar devices use DRAM to store routing tables and manage the flow of data. It's an essential component that keeps our interconnected world spinning. As you can see, DRAM plays a vital role in many of the devices we rely on every day. So there you have it, a crash course on DRAM, its types and its applications. We've explored how this genius piece of technology, with its capacitor-based storage and refreshing system, supports both read and write operations. We've also delved into the various types of DRAM, from the traditional asynchronous DRAM to the high-performing synchronous DRAM, and even the specialized graphics DRAM designed for graphics processing units. We've seen how DRAM's higher storage density and its cost-effectiveness make it the perfect choice for main memory in computers, servers, and a plethora of electronic devices. Not to mention its pivotal role in graphics processing units, mobile devices, consumer electronics, and networking equipment. It's quite amazing, isn't it? All these complex processes happening right under our fingertips. Next time you fire up your computer or phone, remember the crucial role that DRAM plays in making it all possible. Thanks for watching and stay curious.